Geometry Notes, Section 8.2, the Pythagorean Theorem, and the converse to the Pythagorean Theorem, and a Pythagorean triple. If you were to ask most people what the Pythagorean Theorem is, they would get part of it correct. They'd say a squared plus b squared is c squared, and then chuckle. Well, the context matters. Squaring a and squaring b and adding them together does not always equal c squared. The context matters. And what is the context? Well, first of all, it has to be a right triangle. If it's not a right triangle, the Pythagorean theorem doesn't make any sense. Second of all, the a and the b that people refer to have to be the lengths of the legs, and c has to be the hypotenuse. We're actually going to use x's, y's, and r's for this. It will become more apparent later why we're choosing those letters. Pythagorean theorem. In a right triangle, that means it has a right angle, 90 degrees. The sum, addition, of the squares of the measures of the legs is equal to the square of the measure of the hypotenuse. So just quick review. The legs are the two sides that make up the 90-degree angle, and the hypotenuse is the side opposite 90. If the situation ever arrives, which you have a right triangle, then we know with 100% certainty that if you square a leg and add it to the square of another leg, that will equal the hypotenuse squared. Please note, x and y are always the legs, and r is the hypotenuse. I try to make y the vertical leg and x the horizontal leg, just like it would be in a coordinate plane. Well, what's a Pythagorean triple? 3 whole numbers that satisfy the Pythagorean theorem. The smallest Pythagorean triple is the 3, 4, 5 triangle. Let's write down some Pythagorean triples. See, a lot of times the Pythagorean theorem, you're going to have 2 whole numbers and then a third number that is an irrational number. But sometimes you get what's called a Pythagorean triple, where they're all 3 whole numbers. So we got the 3, 4, 5 that was just mentioned. Now, any triangle that's similar to this will also be a Pythagorean triple. So if we have a scale factor of 2, we would double these numbers and get 6, 8, 10. That's the same Pythagorean triple. Let's say that this was our base triangle and we had a scale factor of 3. That would be a 9, 12, 15. Scale factor of 4, that would be 12, 16, 20. We could continue that. That's an etc. type situation. This is not the only Pythagorean triple base that you could have. There are lots of others. Let me write down some of these, and then if you recognize these coming up in problems, you are free to do less work and just say, hey, that's Pythagorean triple. For example, you could have a 5, 12, 13. This is 25 if you square it, 144 if you square it. If you add those, you get 169. 13 squared is 169. There is also a 8, 15, 17 Pythagorean triple. There is a 7, 24, 25 Pythagorean triple. There is a 20, 21, 29 Pythagorean triple, a 9, 40, 41 Pythagorean triple, a 12, 35, 37. Am I asking you to memorize these? I am not. Minimally, you would memorize 3, 4, 5 and the 5, 12, 13. If you wanted to take it upon yourself to memorize some of these other Pythagorean triples, go for it. If you don't want to, it's fine. If you don't recognize it's Pythagorean triple, it's going to add anywhere between 10 to 90 seconds to the problem. Let's check out number 1. Use the Pythagorean theorem to find the missing measure. Give exact answers and rounded answers, if needed, to 1 decimal point. First of all, does Pythagorean theorem apply to this? It does. We have a triangle that has a right angle. Now I recognize right now this is a Pythagorean triple. This hypotenuse could be thought of as a 5 if you cut it in half. The 6 could be thought of a 3 if you cut it in half. So that means this would be a 4 if you cut it in half. This is a 3, 4, 5. If you double it, it's a 6, 8, 10. So we could simply say y is 8, Pythagorean triple, it's a 3, 4, 5. Now if you don't like that, it's fine, you don't have to. Here's how you would do it algebraically. X squared plus y squared equals r squared. Every time you use Pythagorean theorem, you need to write that down. X is 6. We don't know what y is. And we know that r is 10. So that's 36 plus y squared is 100. Y squared is 64. So then y is plus or minus 8. Anytime you initiate a square root, it's plus or minus. In the current context of a triangle like so, we're always going to choose the positive answer. Let's check out number 2. Is this the Pythagorean triple? One leg's twice as big as the other. I don't believe so. So let's see if we can use the Pythagorean theorem. We can because it's a right triangle. So x squared plus y squared equals r squared. X is 4. Sorry, threw an equal sign in there. Y is 8. We don't know what r is. 4 squared is 16. 8 squared is 64. R squared's r squared. That's going to give us 80. Is r squared. If we then square root both sides, try to get r by itself, we're going to get plus or minus the square root of 80 is r. And then this is the whole reason we did section 8.1, simplifying radicals, because we're going to have radicals all over the place. Can you think of a number that goes into 80 evenly that's a perfect square? 4 does. I think 16 actually does. Let's go with 4 for right now. So it's 4 times 20. 20 is 4 times 4 times 5. So this is 4 square roots of 5. We got a pair of 4s. So 16 times 5 must be 80. Let's just check to make sure because I am that stupid. Yep, that's 80. Just to make sure that we did this correct, you could always check. We could say 4 squared plus 8 squared. It says that's 80. And then is 4 square roots of 5 squared. Is that also 80? Sure is. So we've done this correct. Now the reason we said plus or minus, anytime you initiate a square root on both sides, you have to do plus or minus. We concluded it was positive because in our current context, we're always going to have positive answers. So the length of r is 4 square roots of 5. That's probably as hard as it gets, the one we just did. Maybe 13.3 is harder, I don't know. Pythagorean theorem. I don't recognize this as a Pythagorean triple. In fact, it couldn't be. This is not an integer, not a whole number. X squared plus y squared equals r squared. X, I'm going to call the horizontal length, which is 11. Y, I'm going to call the vertical length, which is square root of 10. Don't know what r is. 11 squared is 121. What's the square root of 10 squared? The square root and the squared cancel, so that's just 10. It's going to give us 131 as r squared. If you square root both sides, I just realized I didn't follow the directions on the previous problem. We'll fix that in a moment. We get r is the square root of 131. I'm pretty sure 131 is prime. The directions say give exact answers. So like for number 1, we gave an exact answer. And rounded if needed. Well, this isn't needed because the exact answer is a whole number. Number 2, we did not give a rounded answer. 4 square roots of 5 is 8.9. That's an approximation. That's why I wrote a squiggly equal sign. And the square root of 131, I believe, is 11.4. Exact, rounded. The converse to the Pythagorean theorem. Remember, a converse is when you interchange the hypothesis and conclusion. If the sum of the squares of the measures of two sides of a triangle equals the square of the measure of the longest side, then the triangle is a right triangle. Let's draw a picture of the situation. Some random triangle. Now not assuming, you're going to be given the lengths of these things. So let's say that r is the biggest side. And if we square x and we square y and add those together and it equals r squared, then according to the converse to the Pythagorean theorem, we know that triangle cat is a right triangle. That's the converse to the Pythagorean theorem. Determine if the following can form a right triangle. We always assume that the biggest number is the hypotenuse. Hopefully you recognize this as the Pythagorean triple, which I'm saying you can abbreviate PT. This is a 3, 4, 5. So the question is, determine if the measures can form a right triangle. Sure. Right triangle. Number 5. Let's say you don't recognize whether this is a Pythagorean triple or not. They're all integers. So x squared plus y squared, does it actually equal r squared? So we're trying to figure out. Let's say x is 12. Now we have to choose this 20 for r because it's the largest side. Let's say y is a 16. Now you might be asking yourself, does it matter which is x and which is y? It does not. This is 144 plus 256 equals 400. So we get 400 equals 400. Are those equal? Sure are. So this is, in fact, a right triangle. This is also, if you would recognize it, this is Pythagorean triple 3, 4, 5 with a scale factor of 4. Number 6, is this a Pythagorean triple? This one here is going to be r. So we got x squared plus y squared is r squared. Let's say x is the 34 and y is the 18. You can use either one for x or y. Now I got to use a calculator for this because I don't have to. I'm choosing to use a calculator because I don't want to write down the multiplication longhand and I don't know any of these squares. 34 squared is 1,156. 18 squared is 324. And 39 squared is 1521. That's 1480. Does that equal 1521? It does not. So I'm going to go back and say, hey, these are not equal. Not a right triangle. Number 7, we got to be careful on number 7, because if you don't round correctly, you're going to get the wrong answers. And when I say round correctly, I mean don't round at all. So we're saying this is r, it's the biggest side. So I'm going to have 3.87 squared plus 4.47 squared equals 5.91 squared. Using a calculator, 3.87 squared. Now, a mistake people will make is they will say, well, I'll just round this to one decimal place. If you do that, you're going to get the wrong answer. I'm going to round it to as many decimal places as I was given. If I take 4.47 squared, I get 19.9809. Going to use as many decimal points as it gives me. 5.91 squared is 34.9281. If I add these two numbers together, I'm going to get 34.9578. Is that the same as 34.9281? Different numbers. Therefore, not a right triangle. Two more problems. Get you out of here. Number 8, in a right triangle. So might as well draw a right triangle since we know it is. The measure of the legs are 8 and x plus 7. It's terribly written. I apologize. And the measure of the hypotenuse is x plus 10. Find the value of x. Well, using the Pythagorean theorem, now here's an example of using x squared is probably not the greatest thing in the world. There's an x in the problem already, and that's kind of confusing. I'm just going to change this to w. You wouldn't have to. You could use a, b's, and c's for this. So w, which I'm saying is this, is the sum of x and 7. Y, I'm saying is 8, and r, I'm saying is the sum of x and 10. Now you got to be careful here, folks. If you let your guard down, you're going to say that x plus 7 squared is x squared plus 49. And that is awkward if you do that. X plus 7 squared means, write this off to the side, it means that we're multiplying x plus 7 times x plus 7, which in turn means we have to distribute the x, and we have to distribute the 7. This is going to give us 4 terms, and the middle 2 terms are going to be like terms. We can combine them. This is going to be x squared plus 7x plus 7x plus 49, which is x squared plus 14x plus 49. I do not need to see this work. If you need to do this work, to do this correctly, cool. It's not required from my standpoint. So this is going to be x squared plus 14x plus 49. 8 squared is 64. X plus 10 quantity squared. Square the first term, square the last term, multiply the first and last term together, and then double it. Every time you have a perfect square trinomial, that's how it ends up being. Now, you should be nervous. We have x squareds and x's that aren't squared, which likely means we need to get all the terms on the same side and factor. We are lucky, because if we start to get all the x squareds together, we subtract x squared from both sides, they cancel out, and that makes our life much easier. If I then, let's say I want to combine these two terms, that would be 13, 113. And let's say, let's just do that for now. And subtract 14x from both sides. And subtract subtract 100 from both sides and get 13 as 6x. And I'm going to get that x is 13 over 6. Awesome. Let's check out this last one. The diagonals of a rhombus. What was a rhombus? A rhombus is a quadrilateral with all four sides the same length. You could also think of it as a parallelogram with all four sides the same length. The diagonals of a rhombus measure 30 centimeters and 16 centimeters. What are some properties of the diagonals of a rhombus? For one, the diagonals of a rhombus bisect the opposite angles. This is a parallelogram, opposite angles are the same, so those are cut in half equivalently. If I draw my other diagonal, it cuts those angles in half equivalently as well. Other facts about the diagonals of a rhombus: they bisect each other. Other facts about the diagonals of a rhombus: they intersect each other, forming perpendiculars. Now, how is that relevant to what we're talking about? We're talking about triangles, not rhombi. That's because this is a right triangle. In fact, if you remember, all four of these right triangles are congruent to each other. So back to the problem. The diagonals are 30 and 16. Well, if this whole diagonal is 30 and I cut it in half, half of it's 15. If this whole diagonal is 16 and I cut it in half, half of it's 8. Use properties of a rhombus, we just did. Pythagorean theorem, we will. Find the perimeter. So the perimeter is going to be, I'm just going to write this down. The perimeter is going to be 4 times r, where r is the length of a side. Just got to figure out what r is. Using this right triangle here, I can see this is a Pythagorean triple. This is an 8, 15, 17. If you don't recognize it, use Pythagorean theorem and you'll find that it's 17. So the perimeter is 4 times 17, which is 68, where we given units centimeters. Perimeter is 60 centimeters. I'm sorry, 68 centimeters. I think I drew an 8 and it turned into a circle when I wasn't looking. Alrighty, that concludes the notes. Please do the homework as outlined by the website.